series of exciting lightning talks. We have hopefully 5 people in quick succession. And we'll start with Vladimir Moolle, who would talk about declarative retranslations in QML, which I'm looking forward to because I've had his issues.
Thanks. So the question is, how do we actually retranslate QML strings, provided that the stock setup doesn't actually allow us to do this, right? So that's what you commonly have in your QML files, QtWS, and as soon as you switch languages, right, install a new translator, for example, it doesn't change. So there were some attempts to deal with this internally and add some magic, but those were abandoned, but you can still have the links when you get the PDF. So there are a couple of workarounds. And the first one is what probably most people do is essentially adding an empty string to all your QtWS-related strings, right? And then emitting essentially a fake change signal, which, provided that the QML engine does not optimize the expression reevaluation well enough, turns into the whole thing getting reevaluated and the translation being done for the new translator, which kind of works, but again, it has the misbenefit of lacking any proper guarantees. Then there's the second way, which is using this, notorious retranslateUi JavaScript function, and essentially traversing all your text-related QML elements and swapping text manually, which has, again, an unfortunate feature of essentially being somewhat error-prone, tedious to implement, and then it actually can break your bindings, right? Then there's kind of a brute force approach of reloading the whole set of currently visible items, which works, but you lose the text selection, right, scroll position, and such things, which essentially may force you to introduce things like view model for the only purpose of keeping those things kind of intact when the UI goes back, right? Then, okay, let's see what we can do here. So one thing to note is that essentially what QML deals with really well is properties, right? Because properties have change signals. And if, for example, every string we would like to retranslate, right, was exposed somehow as a property, right, but not like a QtWS essentially function or macro call, it would work. So one could even try taking all the strings and kind of exposing them as a property per string, right? But that would be, again, tedious, and no one would probably prefer this path for a more or less serious application. On the other hand, if we look at dynamic retranslation, it may seem to be something like a result of a query, right? You query the translator, and you supply a single parameter, which is the string to be translated, essentially. So this suggests some form of a pattern. And this pattern, let's name it, let's say, active request. I Googled this a little bit, and it seems not taken by many other patterns, so let's name it this way for now. So let's imagine we have a QObject, right, exposed to QML somehow. So far, let's say somehow. And it's parameterized by several, and in our case, it will be one property or attribute or whatever, which may even not be accessible from QML when you need the final value from this query or request. So on the inside, this thing would watch for some specific events. In our case, again, this would be language change events, right? And then we could use this way of dealing with things. We could use some sort of a QInvocable on another QObject, which would produce us this QObject that we were just talking about. And then on that, we could retrieve a property value. So this thing should obviously work. And in fact, it actually works. So we will see the code in just, essentially like a minute. And we have 6 left. So the solution could be creating 2 classes, basically. One, which I named translator, which unfortunately conflicts with QTranslator and its descendants, but it probably is a better name than something named like QS with a tier property, right? For QSTR to match the original QSTR. So let's just have this slight name clash here. So translator, which provides a QInvocable, creating instances of another class, translate request, right? And this translator, it actually watches language change events. And translate request actually stores the strings which should be translated. And then it gets notified by the translator. Essentially, there's a signal emitted, gets notified on the language change events, and emits its own change signal on a property, which essentially is the property we need for our translatable QML elements. So if we look at the code, we'll see that here's a base class for this active request. It's really small. It's just basically there to kind of document the intent and put the property here, right? And then a single virtual method. Name is generic, but that's OK for now. Then we have this translator header file, where we have this translate request class and the actual translator. And if we go into the implementation, we will see how it installs an event filter, filters language change events, right, and emits this language change signal. The purpose being, of course, that there is one signal emission and one event filter, and not an event filter per translate request. Sorry. Now, then translate request actually connects to this signal, right? And upon change, it emits its value change signal, which makes the property essentially be reevaluated on the QML side, right? And as its reader gets called, the proper translation gets returned. So we have, let's get back to the slides. This code, and it's working, but there is a caveat. So the caveat is actually something happening when the aforementioned sequence of events takes place. So if you guys can spend like 10 seconds guessing what goes on here, I would really kind of appreciate this. So let's imagine this value thing actually emitted a changed signal, right? So what one would expect is that essentially this whole thing, well, more or less stays in place, right? Because it was signal emitted here, where the mouse cursor is, and then essentially you get a new text value. But what actually happens is almost like in the case when you append an empty trig, an empty string using that original trig that we saw before, the whole expression gets reevaluated, and you essentially get a fresh new value of this translate request object, which means these objects kind of keep floating around until they are garbage collected, which is probably quite unfortunate. So the trick here is to split the binding into parts, which is more or less harmless because you probably would want to have your visual elements kind of more or less standardized, right? So for example, for text, we could invent something named, for example, tr text with these two properties, which avoid this issue and work quite nicely. So here's the demo. And I have like 2 minutes. OK. I have something named Quack translator. So it's about ducks, essentially. Like, you know, Donald the duck, right? And this thing essentially translates everything into Quack language, right? So short word becomes one Quack, couple longer word becomes Quack Quack, and so on. Punctuation is kept, and uppercase letters are preserved. So we have this. This is the logic for it. And then we have this little controller class, again, and a header named Quack. And we have this, the thing I'm proud most of. You see, import cute quick, import cute Quack. Yeah, and when you run it, you see this lorem ipsum thing. OK, it starts, and we have like 30 seconds. And when you press this button, which is again translatable, you see it all changes, including the text in the button. So it's, and the QML is just the plain QML you would kind of expect, you see. it's the tr_text class. And there is also a tr button, which uses the very same approach. Again, all declarative, all works. That's it. And the final slide, I guess. Questions? 15 seconds. I guess no. Then thank you. Extra links, and the source is on GitHub. Thanks.